Yes. So I'll look at this question on integration. So I'll say whenever you see numbers on the integral, this symbol here is called the integral. The number on top is the upper limit. The number at the bottom is the lower limit. So what happens is whenever you see these numbers, after you integrate your expression, okay, you're going to substitute this upper limit, integrated expression, and you subtract it from where you're going to substitute the lower limit into this expression. Okay, so as we can see, this is the law of integration. So basically, what happens is your power, in simple words, whenever you have a power, just add a 1 to that power. And then in the denominator, whatever operation you have done with the power, you also do it in the denominator. Okay. So let's just start a little light. Can someone integrate this for me? Has anyone got the answer? Mm-hmm. Correct. Plus what? When there are no limits, always add plus c. C just represents that a constant will be made. Okay. It just represents a constant. Okay. So yes, x to the power 3 over 3 plus c. Colleagues, are we all okay with this? Any questions? Yes, we're all starting from scratch. We're all starting from scratch. Uh, we are all starting from scratch. Okay. Okay. So this is here. As you can see, here is the rule of integration. Okay. As I said, you add a 1 to the power. Okay. And what you do with the powers, you also do in the denominator. So as you can see here, x to the power 2, you're going to write it as x to the power. As I'm explaining for the others, others can try to integrate these 3 down here. Yes. So it's x to the power 2. Then you're going to add a 1. Okay. Then what you do with the power, you do it in the denominator. So here you have 2 plus 1. That's how you get x to the power 3 over 3. Then you add a plus c. Is that okay, sir? Okay. Any questions, colleagues? Okay, let's try to integrate these three here. Colleagues, as you are trying, just remember here is the law here, okay? You look at the law and you try to apply it here. Yes? Mm. Sa. Okay, just hold on. But thank you for your try. Anybody else? Uh-huh. Thank you for your try. Thank you for your try. What was that? No. Oh, Madam Beth. How are you, Madam Betha? I'm fine. Yes, Madam Sylvia. Yes, yes, Madam Sylvia. Mm. Yes, the X is invisible. You bring mm-mm, X to power zero. Yes. So let's try again now. Yes. You've forgotten one thing. Yes. Please go ahead. Mm-hmm. Mm-hmm. 3x. Uh-huh. Yes. Colleagues, are we all okay with this? Mr. Fred, are you okay with this? Madam Betha, Madam Florence, Miss Anchimoni, I haven't heard you today. Okay, okay. Madam Geraldine. So the secret is this. Add a 1 to the exponent, and what you do with the exponent, do it at the bottom. Okay, add a 1 to the, as you can see here on top here, okay, you're always adding a 1 to the exponent. Then what you do at the top, you also have to do at the bottom. Okay, do not worry, sir. Good evening. Okay. Okay, can we try this one? Okay. Sir, you haven't given us examples similar to that. Colleagues, this is how university is, okay? We are building. We are building, okay? So, colleagues, this 1 over x squared, when we apply the law of indices, what does it transform into? Mm-hmm. Hmm. No, 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 no. Ah, okay. Here, colleagues, like okay, there's a reason why I've brought this to here because I want us to remember the laws of indices. Okay, the laws of indices. Now, colleagues, remember this law of indices: a to the power negative n equals 1 over a to the power n. Never forget this law, colleagues. Please write it down. Okay. Yes. So you are going to apply this law of indices here. So if we apply this law of indices, colleagues, Mr. Twambo, your second try, when we apply this law of indices here, what does it become? Do not worry, this video is being recorded, colleagues, okay? So if you've got bad network, the video. Thank you for your try, madam. But just try one more time. Look at the power which is being involved in this question, then use that power. Mm-hmm. Thank you. Yes, yes, yes. Okay, okay. So x to the power negative 2. So let's integrate, colleagues. So now it's x to the power negative 2. Okay. Mr. Chimunya, okay, here just try, attempt it, okay? Just look at what's happened in the previous examples. And for everyone who's still struggling, just look at the previous example, okay, and then try to apply it to what you're seeing now here. Uh-huh. No, 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 no. It's not, sir. You just convert, then now you integrate. You integrate. Excuse me. So this law of indices, please, from today onwards, just remember it by heart. You're going to see it next year in second year being applied. And in third year, those doing business admin, you will see this again also in third year. Those who are doing accounts, You on third year, fourth year. Ah, fourth year, we are going to see these come back again. Yes, fourth year. Those doing business administration, second, third, and fourth year, you're going to see this again. Those doing human resource management, I'm not really sure. Not really sure for you guys doing. And project management, I'm not really sure. Yes, can somebody give me the answer here? Mm-hmm. Oh, hmm. X just by itself. Okay, just look at your workings again. Uh-huh. Yeah. Yes. Yes. Colleagues, are we all okay with that? Madam Sylvia, please break it down. Please break it down. Yes. Maybe they'll understand from explanation. Then you apply the laws of indices again, okay, because as you have seen, x to the power negative 1, so you get its reciprocal. So it will come down here. So the answer now becomes 1 over negative 1x, or simply put as negative 1 over x. Let me repeat myself. Okay. Once you've reached your final answer, okay, never leave it with a negative power, right? Never leave your answers with negative powers. If you leave it like this, yes, you'll be marked, okay? You'll be marked correct, okay? But you just want, if you see in most maths textbooks and everywhere you're going to see, you never leave an answer in negative, okay? So this x to the power negative 1, okay? You convert it again, it becomes 1 over x. So you have 1 over x over negative 1. So this x will come down here. Colleagues, do we need to see how the x comes down here, or it's just okay like how I brought it here? Okay. 1 over x divided by negative 1. Welcome back to grade 3 mathematics. This is grade 3 mathematics, colleagues. 1 over x. Now remember, when you're dividing fractions, the sign changes, right? It becomes a multiplication. Then the denominator comes on top and the numerator goes down. You can put 1 over negative 1. 1 over negative 1x. You multiply x times negative 1, that is negative 1x. Are we okay with this, colleagues? Please don't say that I won't attempt this in the exam. Attempt it, colleagues, okay? Don't say that, it's looking difficult here, I won't attempt. No, 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 no. You have to attempt. Yes. Any questions, Mr. Twambo, Mr. Chimoni, Mr. Frederick, Madam Beth, Madam Geraldine, Madam Sylvia? I know you're okay because you did you did helped in the explanation. Yes, yes. Just like this negative 1 over x. Oh, what you're saying is this, to put at x to the power negative 1, like this. Negative x to the power negative 1. No, just yeah, you're correct in saying that. But as I said, your answers shouldn't have a negative power. So you leave your answer as a fraction. You just end the answer. Yes, negative 1 over x. Yes. Powers, negative powers. Because if you do this, is negative power. But I can see you've grasped you have now remembered the law of indices. Because what you are saying is right. You can transfer this back to that form, but as I said, the answer shouldn't be the negative power. Before I go to Mr. Chimonia, is that okay, Mr. Twam? Okay, Mr. Chimonia. Oh, yes. Oh, yes. You are paying attention, sir. Yes. Plus C. Plus C. I was caught up in explaining this. I forgot about that. Plus C, yes. Yes. Show it through it. It's good you've also asked that. Show it through your workings. Show it through the workings. Yeah. Just show it throughout all the workings. So thank you for that point, Mr. Fred. Yeah. Colleagues, throughout your workings, please show that C. Okay. Maybe your next question is, what if you don't show it through the workings? What happens? Is that the next question? Mr. Trump, if they don't show the C, what happens? Will you be penalized? Yes. I believe Professor Abuino can excuse you. Okay. Probably he can excuse you. But at the final answer, it shouldn't miss out because I believe you can miss a mark if the final answer you forgot to put the C. Okay, colleagues, can we try this one before now we try? a similar question to what came to the assignment. This one, the integral of the square root of x. We have to apply a law of indices. If we apply the laws of indices, what does this become? Let me write the law here. Always remember the denominator is the number on the root. Okay, the denominator is the number on the root. Maybe let me put the number here. I'll put the 2, but they'll never put the 2 for you there. Okay, so if we apply the laws of indices, what does the square root of x become? Maybe I should put it like this. What does x become then? Wonderful, madam. Wonderful. It becomes x to the power half. That's Madam Florence. Okay. Yes. Colleagues, are we okay with this? If you look on top here, this n, think of it as like this 2 here. Okay. Then this m here, think of it as this 1 here. So it becomes x to the power 1 over 2. Okay. So anytime you see a square root, and maybe they're telling you to differentiate or to integrate, automatically just know that that square root becomes x to the power half. Okay, colleagues? So even this law of indices here, please remember it. You can write it down. Just write it down on a paper. Yes. Okay, so x to the power half. Can we integrate now? Now, if you do not like working with fractions, because I've seen a lot of people don't like working with fractions, you can convert this into a decimal point. It will actually make life easier, and you won't be penalized. Okay, you will not be penalized. So if you want, you can say x to the power 0.5. So when you're giving me your answer, you tell me I use the fraction, I use the decimal. Then you give me the answer. Mm-hmm. Oh, where here? Oh, if it's 3 here, right? Okay, so this becomes x to the power 3 over 2. If it's 2, what's this? X to the power 2 over 2 then just becomes x to the power 1. You'll never see a 2 here. Yes. If there was a 7 here, you would say x to the power 7 over 2. How I remembered this law, I just remembered this. The denominator is going to be the one, in front of the root. Okay. Okay, please try. Mm-hmm. So how you lost when you got the correct answer? That is correct, madam. Yes. Wonderful. Use the decimals. Okay. Yeah, in life, just use what's consumer friendly. No need to trouble yourself with the fractions. Because with the fractions, there's a lot of work. But I'll show you how you do it with the fractions. But has anyone tried with the fraction? Madam Yvonne, you've been quiet today. So with the fraction, what's our answer? Yeah. Oh. Okay, is anyone attempting the one with the fraction? Though? Has anyone attempted the one with the fraction? Half plus 1, colleagues, half plus 1 is 3 over 2. Are we okay with how this 3 over 2 came? Yes. Mm-hmm. Mm. Yes, 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 yes. Then this 2, just bring it on top here. Do we want to see how this 2 comes on top there? So you can't trust me and say, "Okay, Mr. Mwabaya, I trust you that 2 goes on top there." You can't just trust me. Okay, let me show you how it comes on top there. It's like x to the power 3 over 2 divided by 3 over 2. Then remember, when you're dividing fractions, then 2 times x to the power 3 over 2 is 2x to the power 3 over 2. Yes. Then we're not done. Okay, colleagues, we are not yet done here. We have to convert this back into the root form. So what does this become in root form? Square root of x to the power 3. Okay, now colleagues, any questions? Oh, plus c, yes, plus c. I don't know why I always forget to put the plus c. And it's because I'm writing a lot, so there'll be points I'll feel lazy to put the plus c there. Okay, so now let's go. Yes. Where have we taken the 2? Yes. Yes. So you are paying attention. That's good. So, uh-huh. Okay. Sure. Uh-huh. Yes. You're talking about this part where we start solving the fraction. Uh-huh. Here, or here from here, How it has changed to this? Okay, it was shown here, sir. Have you seen here? Uh, uh-huh. Okay. Yes, you added this. You added this half plus one to get this. Uh-huh. Oh, okay. So you're talking about this part here where you were solving the fraction, right? Okay. So 1/2 plus 1/1. Uh-huh. So now you're asking how I solved the fraction. Okay. You multiply the denominators. This is called the butterfly method. Multiply the denominators first. 2 times 1, 2. 2 times 1, yes. Then you come to the bottom right wing and you go diagonal. 1 times 1, 1. Then you go to the bottom left wing and you say 2 times 1, 2. Yes. So on the numerator, you have 1 plus 2. Yes. Mm-hmm. Two divided by 2 divided by 2. You can do that also, madam. Yes. Okay. Any other queries? Remember, I'm here to serve you guys. So if you still got queries, ask. Okay, ask. Are we all okay with this? Okay, I'll assume the silence means we are okay with it. If you still have queries, uh, yes, sir. Yes. Yeah. You're talking about, okay. So you're talking about when we moved from this point to this point, right? Is this what you're talking about? How we moved to this point to this point? Okay, it's here on this division here, sir. Okay, it's the same as saying x to the power 3 over 2 divided by 3 over 2. Then the division sign becomes the multiplication sign. So this 2 comes on top and this 3 comes at the bottom. So then when you multiply 2 times x to the power 3 over 2, that's how you get this 2x to the power 3 over 2. Think of it over 1. Then 3 times 1, that's how you get this 3. That's how the 3 remains there. Is that okay, Mr. Chimunyo? Okay. Do not worry, I've got 50 questions ready for you. You'll get the concept. Okay, colleagues, so now we've come to this one here. Okay, so the first thing that we need to do here is you need to integrate x squared. You need to integrate this 4 here, and you need to integrate this 4x to the power negative 2. So can we integrate first so that we hear what answers we get? This time there will be no plus c. When there's an upper and a lower limit, there is no plus c. Okay. We are starting to solve this question. So we want to first integrate x squared. We integrate this 4 and this 4x to the power negative 2. So I want to hear the answers. So that's what I'm just waiting for, to hear the answers. Mm-hmm. Yes, please do. Like this. Like this. You've added a 1 to this 2, right? You did this x to the power, yes, 2 plus 1 over 2 plus 1, right? So, yes, you will come down. So your answer will come down to x to the power 3 over 3. Wonderful job, sir. What about the 4? Mm-hmm. 4x to the power 0 plus 1. Uh-huh. Uh-huh. Yes, so just conclude this one. Yes. So 4x divided by 1, you just get 4x. Okay. All right. And the next one here. Mm-hmm. To the power negative 1. Mm-hmm. Over. Okay, okay. Mm, yes, yes, yes. Then these signs, negative and positive, what does that make? Negative. So it becomes now x the power 3 over 3 minus 4x minus 4 over x. Colleagues, do we know how this 4 over x came about? Okay. So I don't need. Yeah. Yes. Thank you, sir. Are we all okay with this before we move to the next step? Uh-huh. Mm. Yes, Kylie, x to the power negative 1 is 1 over x. So 4 times 1, 4. X times 1, x. Is that okay, madam? Okay. Any other questions before we move to the second stage? Because the answer is not complete. We've still got these two to deal with, the upper and the lower limit. Okay, so what you're going to do next, colleagues, is your upper limit, where there is x, you substitute it with 4. Okay, so this will become 4 cubed over 3 minus 4 multiplied by 4 minus 4 over 4 like this. Minus. Always, it's always going to be minus, colleagues, okay? Always going to be minus. Minus the lower limit you also do the same. You substitute here. So where there's x, you substitute it with 1. So you have 1 cubed over 3 minus 4 times 4 minus, 1, not 4. Ish. Minus 4 times 1. Then here you have minus 4 over 1. So here there's a 4 on top and then the 1 at the bottom. Yes. Okay, colleagues, that's how you deal with these upper and lower limits. So let's get our final answer. Yes, so can we get our answer? Four to the power 3, 64 over 3, minus 4 times 4, that is 16, minus 4 divided by 4, that is 1. 1 to the power 3, that is 1, so you have 1 over 3, minus 4, minus 4 divided by 1, that is 4. If you do not want to work with fractions, you can work with decimals, colleagues, all right? It's okay to work with decimals. Okay. 64 divided by 3 into decimal, what do we get? Huh? 20? Okay, 21.33 minus 16 minus 1 minus 1 over 3. 0.33 minus 4 minus 4. We would have even done -4 minus 4, -8, either way. Mhm. 21.33 minus 16 minus 1. What do we get? Imagine if they told you no calculators in the exam. Are we getting 4.33? 10.33 minus 4 minus 4 -7.3. Okay, so excuse me. Ish, Mr. Emmanuel has joined late. Mr. Emmanuel, good evening. Anyway, don't worry, it's being recorded. You have joined near the conclusion. Okay, sir. Okay, sir. 12. Colleagues, are we all getting 12? Okay. Yes, with maths, you can use whichever way you're comfortable with. And I'm happy you used the fraction way. Uh-huh. Which, which formula? Teach us your formula. If it's in line with the standard rules, maybe you send me a screenshot of it so that I see if it's in line. Because workings are very important. So they see you're doing something different. Whoever's marking will be. Whoever's marking might take it the different way. Okay, yes, colleagues, are we okay with this? Any questions? Consumer friendly, right? Wait until you reach binomial, because binomial is waiting for you. I actually heard that it's even going to be there. It's not missing out. So, colleagues, I believe we can answer also this one. Can we answer this one here? I have to switch classes. The students who are crying for me, sir, we need you. Tomorrow is our final paper. So, can I just attend to their final paper, colleagues?